My name is Komljenovic. I'm the CEO of Nexus Photonics. We're very excited to be here. Thanks, Mark, for inviting us. So what is the problem that Nexus is addressing? We see a huge opportunity for integrated photonics in the emerging applications. Some of them are listed here. Obviously, quantum is the centerpiece of today's talk, but there are many others. And they differentiate from datacom and telecom markets in the requirements and the wavelength of operation. Typically, quantum is defined by the transition of the atom or other requirement. For AR, VR, we see a need to make PICs that are going to operate below 1 micron, mostly for sensing or for displays. Healthcare, it's same like quantum. It depends what you're sensing and all others. And what they have in common is that operation actually should be pretty broadband, going from UV to infrared. If it's going to be a wearable, it has to be small and light. If it's going to be quantum, it has to be extremely high performance. Every photon counts. And if it's going to be battery operated, it needs to have high power efficiency. And so to enable that future and emerging applications, we are fully committed on developing and commercializing a fully integrated photonic platform with on-chip sources. Today, if you're doing things, as Zach has also shown, you're going to have a small, nice component, and then you have racks. We show images available online from Xanadu that's going to have racks and millions of dollars of equipment. And to scale the technology, we really have to leverage photonic integration. High performance components today come with high cost, and if you go with low cost solutions, they have poor performance. So solution is to develop a ground up photonics first broadband integrated platform. I'm going to talk a little bit more about the particular platform on the next slide, but I want to highlight the benefits that this type of integration brings to the end user. First is size. On the upper left, you can see a laser that you might recognize. It's a pretty nice laser, very expensive, very large, and very sensitive to vibration, shock, etc. Next to it, you see a Nexus equivalent, which in millimeter size gives you all the performance, roughly 2 orders of magnitude lower volume, and it's extremely robust, no mechanical parts, same level of performance. At the same time, we can reduce the cost. We can, of course, use legacy photonic packaging, but because we're using silicon as a substrate, we can actually leverage a lot of lower cost silicon photonic packaging or silicon chip packaging. And here you see a move from a traditional hermetic butterfly package to really ultra low cost. We're talking now cents to put a PIC that's going to work free space with your system. In terms of performance, we don't have time to cover. So if you're interested, feel free to reach out. But as a high level, we really offer state-of-the-art performance in a fully integrated platform. Our lasers work up to 185 degrees C. They have very high wall plug efficiency. In terms of line width, they're arguably the quietest sources, at least at this size, with line widths going below 100 hertz. And the platform is extremely broadband. A single active device as a laser can typically tune 10 terahertz, and then the whole platform can support more than 240 terahertz. And the last part on the lower right is the key point of having on-chip sources. So here you can see a wafer with a more than a laser PIC, so it has multiple functionality that's being automatically tested at wafer scale before simulation. And in this way, we can determine known good dies before packaging. This is crucial for scaling and also achieving high density. You can see the light because it's operating below the silicon band gap. So how does the platform look like? It's actually pretty flexible, but the main workhorse is silicon nitride waveguide with extremely low loss. Here you can see, maybe it's a bit hard to read, but losses are in the order of a dB per meter or lower, depending on the wavelength range. And then on top of these nitride waveguides, we integrate 3-5 materials in a heterogeneous wafer scale fashion to provide optical sources at a really broadband operation. Here you can see some examples of an indium phosphide 1550, gallium arsenide at 1 micron, gallium arsenide 780, and early gallium nitride results as well. And it's not just the optical source. You can do all other components that you might be familiar with if you use traditional silicon photonics. So you can have waveguides, bands, splitters, crossings, filters, high Q resonators, etc. In terms of actives, you can have whole set of lasers, amplifiers, photodetectors, and modulators. So how does it look? One thing is our laser is state of art, but it can go way beyond that. It can be a customer-specific photonic integrated circuit that embeds multiple functionalities and gives even more benefit of integration. On the upper left, you can see 2 examples. One is a laser that's split into 2 outputs. One is amplified, and you have monitor photodetectors to control the powers. So in this way, you can maybe suppress RIN or generate sidebands. The second pic shows an example of two lasers coupled to the same waveguide. You could do like a blue and red shift to whatever you might be needing it for. On the lower left, you see automated testing on wafer scale again. Now the light is red. These are rubidium-based pics. And we fully qualified before singulation. In the center, it just shows you how we scan across resonances. These lasers can be very finely controlled, locked to the atomic species of interest. As a final point here, we would like to say we make things through commercial foundry supply chain, which gives you very high yield, very high uniformity, and very high functionality, and making pics that are more than a laser. On the lower right, you can see a screening example of a wafer. So this, to control the process, we scatter exactly 500 lasers and 500 PDs that monitor the lasers across the wafer. And here you can see screening results of a laser threshold and photodetector dark current. Extremely high uniformity and yield. So how to work with Nexus? So if you're interested in lasers and PICs, please reach out to us. We have a US-based, commercial foundry-based supply chain. Nexus can support the whole path from initial idea of your product and the design to fabrication with our foundry partners, to testing it for known wafer good dies, to packaging and delivery to the end customer. We're running standard processes, but we can also do custom processes to meet your goals. We're a platform company. We design, develop, and deliver photonic integrated circuits. And our transformative technology really allows you, unprecedented performance, cost, and footprint improvements. So thank you for your attention. You have my contact details at the bottom of the slide. Thanks, Mark.